Oops, look at that. My camera is already messed up. Alright. What about now? Okay, there we go. Alright, I don't have a ton of time today, but I really want to get back into the hang of things. So I am going to be listening to the album Ghosts 6, which is called Locusts. It was released by Nine Inch Nails like 2020, something like that. And I'm going to be working on developing in Blender emitting spherical shells that are perturbed by noise. The first pass at this, I am going to utilize just random perturbations for the noise. If I have time, I will update that to utilize spherical harmonics for the noise. The first thing to do is I'm going to construct a sphere, perturb it. Then the next thing I'll do is have it grow with time. So let's get started. Once again, I'm going to do everything inside geometry nodes. This time though, just for funsies, I'm going to delete the cube and I'm going to add a UV sphere object right here at the center. Now this UV sphere object, you'll note, is made up of a bunch of different mesh points. You can see that. So what we're going to do, we are going to randomly perturb them. And I'm going to try two different ways of randomly perturbing them. The first one is we are going to take each and every object and we are going to offset its XYZ randomly. Now, this will be different than our next pass. Our next pass will only perturb things radially. So let's take a look at this. So here we've got our mesh, right? We've got our primitive cube or sphere. What we're going to do is we are going to have operations on this. Let's do. Why don't we do this? We're going to extrude it. Oh, look at that. That's pretty fun. That's not really what we want at all. Okay. So what we're going to do is we're going to take each vertex and we are going to write a new position. So attribute input, geometry read the exact position. Okay. And now what we're going to do is we are going to write a new attribute, set position, and we are going to do a random value. Now for our ID, let's do index, geometry read index. Okay. Now let's duplicate this. Actually, can we get out a vector? Yeah, we can. All right, great. So now we've got this. Oops. So what happens if all we do is replace all the positions with random values? Looks like that. Awesome. So let's now scale this. Yeah, all right. You know what? We will scale this, and then we'll add it on. So let's multiply by, oh, it's turning it all into a scalar. We don't want that. All right, let's do this. Let's do a constant value here for the max. Now let's position. So now, yep, that's modifying that, but it's still giving us a different one for each value. So let's duplicate this. We'll do a min value of 0. Put that in there. Okay, so now we've got our index as our ID, so we get one for each one. I think if we disconnect it, no, I guess that doesn't do anything. Do I need that at all even? I guess we'll come back to that. So now let's add vector math, position goes into that vector, this value goes into that vector, and this vector now goes into position. So now we are offsetting it. So we've got our random value 0 to 1.6. But if I do minimum value of 0 and a maximum value of 0.1, see, it looks like this. So now let's take and let's animate this. Let's take our scene and we will do scene time. We'll take our frame. Actually, we'll take our time. So let's take this. We want this to be sort of seconds. Will be our first value. Now we'll do modulo. Oh, there's no modulo. Is there a modulo? There should be a modulo. Let's do floored modulo. And we'll do this value every 10 seconds. We'll put that into seed. So now, let's see, does this change every 10 seconds? That looks like it changes every second. Mod 10. Yeah. We actually want floored divide. Nope, that didn't do it. All right, we want to float to integer. Let's try that. There we go. Okay, so we've got that. And so now we are scaling that. So we've got our sphere. It's getting perturbed. So let's try scaling it by how far away it is. Okay, so we want to mix vectors. We want to duplicate this. So we've got our min value, our max value, and now we'll do our seed. But we'll do our we will add 1 to this here. So now what we have is we have two different values being generated. This random value, which will be our B vector, and this random value, which will be our A vector. And now our factor here, it will mix them halfway, and we will have our result go here. So now it still doesn't modify the factor. So instead, what we'll do is we will do integer mod with whatever that value is. So we'll come up with a constant value here. This value will be our number of seconds for a given item, for a given state. So now that will also get fed into our mod. I don't know if we want truncated or floored. Now let's just map this. Map range from value. We actually don't want that. We probably want we'll do the truncated mod. We'll map this value from min to number of seconds. I'm sure there's an easier way to do this. Oh my goodness. To that, and then that will be the result for our factor. And so now we'll see it deform from one to the other. Although it seems to be doing things totally weird here. For some reason, the value 5, here let's do value at 2. So this should be every 2 seconds. It should switch smoothly though. Do I have the wrong factors? Is it going from... Do I have it backwards? Nope. Looks like it's actually just repeating. So there's something weird about the way that I'm doing the mods and stuff. So let's see if we can track that down real quick before I get too caught up in this, because again, I have a meeting that I got to go to. Let's just try regular modulo. Yeah, something strange about this. So number of seconds, divide that by the value. We round that to an integer. Maybe I don't want round. I think I want floor. There we no. So that should floor it. So here, this value should go, yeah, here. If I go back here, every 2 seconds, this should update. Yep, it starts at 0. Yep. So here, this is 0. If I go about halfway, 0.5. Or that's a quarter of the way. Here, this should be 1. Okay, so that seems to be doing what it's supposed to. So here, right before the end, yeah, it should be mostly mixing it. So here, it's giving me a random value. 0 and 1 are the 2 different seeds. So these 2 vectors should be different. Yeah, I guess I don't understand why there's a switch over here. Divide. proceed now for the first one. Yeah, I guess I don't understand why it's not just doing a slow, or why it's not doing a smooth transition once it comes on the other side. Maybe I'm just not understanding how the random values happen. But, it's definitely doing a slow mixing here. Here, the seed is 0 for the random values. Here, the seed is 1 for the random values. And on the next step, it should be switching seed 1 to seed 0, or seed 2. And that should also be when it mixes exactly the opposite amount. Let me go ahead and read the index as well, just in case that impacts any of this. Nope, seems like it's consistently doing the different things. And here, this does not map to the exact values that we had here. Okay, I don't know how caught up into this I want to get. But I do think it's important for me at least to understand why I'm getting a sharp changeover in the random numbers in my noise field. Because switching the seed here, maybe there's something else to it. Maybe the seed is also impacted by the time. In which case, that would really be something. I guess that would make sense. So I guess maybe the right thing to do instead would be to well, I'm going to save this because this is the very first thing that I want to try out. And I think that it basically accomplishes what I'm looking at. And now I'm going to save as, and we're going to work on doing a radial noise. So in this case, what we'll do is we'll start out instead by having our random values be floats. And we will multiply those random values. And let me get rid of, you know what, I'm not going to get rid of any of this stuff just yet. We're going to take our random value here. We're not going to mix it. We are instead, actually no, we will mix it. We're going to make it just perturb outward. So let's get rid of our animation for now. We are going to take our position. We are going to add onto our position a random value between minus 0.1 0.1 and 0.1. And we are going to multiply that by a vector created by taking the position and subtracting, actually there's a direction one, isn't there? No, there's not. Okay. We are going to multiply, we will subtract our position vector from 0. We will then normalize it. We'll then multiply it by our random value. Then we will add it. And so now we've got our sphere here. And we are multiplying by a perturbation, or we are perturbing it in the radial direction. So now, given this, we want to make this sort of ebb and subside. I'm going to take the time now to stick this all inside a script. Especially as we start to do more vector math, it's a little bit more frustrating to do. That didn't yet work. There we go. So let me go ahead and grab my import stuff. Simulated orbit visualizer. And we will call this file, how about sphere perturbations. Now we'll get a couple inputs to this. The first one will be the geometry, because we're going to redo this so that we supply a geometry to it. Then we're going to get our positions. So here, let's do ms.geometry. No, don't want any of that. gs.position. So we've got our position. Got our time in seconds. We've got our position. We've got a random value 1. Data type equals, and now let's see, how do I do this? gs.data type, no, is it random value dot, yeah, data type dot vector, position, no, I don't want position equals pos. This random value for that takes a min, a max, and a seed. We'll do seed equals 0. Yeah, you know what, let's not do that. Let's go back to my sphere noise. Don't save this one. Yeah, we got a vector. Min, max will be let's start out with this. Let's see where this gets us. Um, Scripting, open, invalid syntax. Float vector. Alright, so now if we reload this, run it. Okay, it ran. Let's take a look at what that returns us. Gives us this random value. That's not what we want. We want float. Integer. Alright. I guess that did mean float. And I don't mean NS, I actually mean GS. Got multiple arguments for primary arg. Alright, let's do value. That does not have input name value. Alright, let's get back to this. Min equals 0.1, max equals 0.1. This should work for me. Alright, so now we've got scene time equals seconds. We will do GS pos2 equals R1 times pos plus pos. GS dot set position geometry equals geometry and position equals pos2. Alright, so now let's go over here and take a look at our geometry scripting nodes. Alright, so now we've got values that look right. Okay. We're adding that vector onto that. Okay, now let's go back here. We will add this to a new, oh no, sorry. I actually don't want to do that just yet. Let's finish converting all of our stuff over. So, let's go back to what we want to put in for our geometry nodes. We've now got our random values and all that. So, let's see. We want to mix the two. So, our first position, pos I is R1, random 1, times position plus position. But we don't actually want that. Let's just do R1 plus position. Pos F equals R2 plus position. So now we want to mix our vectors. gs.mix, and here this is gs.mix.datatypes.vector. Factor mode, oh, that's data type, is equal to that. And then they are called factor A and B. A equals pos I, B equals pos F. So now let's figure out what factor is. Let's first go over here, we'll reload it, run it, make sure that it runs. Did you mean R1? Yeah, I did. But actually, no, I didn't. I wanted that. Okay, so now let's go back to our modeling. We will add a new object. We'll call it a cube. No, you know what? Layout, add, mesh, cube. All right, we're going to call it a cube so that we know when we get into actually making changes to it, we have it done correctly. So we'll get rid of that input, UV sphere, time varying perturbed sphere, mesh, geometry, geometry, geometry. Okay, great. So now we've got our geometry nodes there. That's fun. All right, so we've got random value times our vector. Oh, our result never comes out. That didn't really work. All right, we've got a group input geometry. We set our position on that geometry. Am I doing that here? Yep, I am. My position, random values, 1 and 1. There we go. I had the random value set to 1 and 1. So let's go back here, geometry nodes. All right, still looks like a cube for some reason. You know what, let's get rid of that. Let's go back here, add UV sphere. We actually want this to be a UV sphere. Add a mesh of a UV sphere. Yep, there we go. We'll set our modifier here to be time varying perturbed sphere. Okay, but our time varying perturbed sphere is not actually perturbing anything. So let's go here. We've got our input geometry. It's getting that. We are setting a position. Ooh, that's why. We are not setting our position. We actually want this to be from the mix result. There we go. So now it's mixing it between the two. All right, so set position geometry equals geometry pos equals, and what do we call the output of a mix? A result. Pos position. Let's see if that does it. Scripting, reload, geometry nodes. There we go. All right, so now we've got our output. Now what we want to do is we want to change our mix factor based on the scene time modded by something. So our factor is going to be equal to TS mod 5. Factor equals TS mod 5 divided by 5. Let's see if that works for us. Let's go back to scripting, reload, rerun. Did it actually do any modulos and things like that? It did. Okay. Look at that. Every 5 seconds, it does the thing. Okay. So our random numbers are still not continuous. And I'm not sure that I completely understand why, but that's a big step forward. Okay. So I'm wondering if how the seeding works here. And if the way to do this is somehow related to generating fully new random numbers, but maybe the trick here is to do mod 5 divided by 2.5 and do 5 minus that. Let's try playing this. No, that just turned everything off. No. All right, let's get rid of that. I still don't know why this isn't why my random seeds aren't working precisely as I would have expected them to. But I think a way that we could get around this is by when it gets to 1, I guess by making it cyclic. And having them offset. So here, let's figure out our iteration count is equal to TS mod 5. We want it, TS mod 2. We'll make it every 2 seconds. And so that can take on values of 0 and 1, right? So when it gets to 1, we want it to, we really need to have 3 things going on, 3 different sets of vectors that we're mixing together. And this is where I feel like I need to sketch this out on paper because all the different modulo arithmetics get really confusing for me. But the next thing that I want to do is we need to figure out how can we, on some time scale, create a new geometry. Um, or if not a new geometry, well, no, actually, we don't actually need to create a new geometry. Um, what we need here is we need to create a set of random values. I'm starting to pick this up now. Okay. We need to, okay. Let's try something different. We now have this working. So let's create a new mesh object. And it doesn't need to be a mesh, it really just needs to be anything that has, n instances. So let's get rid of this for now. We will create a new object. This new object is going to be, we'll just make it a cube for no reason. The cube, we will delete our input geometry. We will create a set of curves. That are well, let's call it a line. No, that's not a line. We want it to be can we say how many points go in the line? No. We'll create a curve, we really just need a whole bunch of points. So we'll do a bunch of points. Okay. And now for each one of these, once we hit, we will instance on points a set of spheres So now we've got a whole bunch of spheres here. What we want to do is once the sphere's index is times 10 or something like that is exceeded by the frame count, we want the sphere to start growing. So we want to, how do we do a conditional? Input. Let's see, we want to select those. I already did selection. Geometry, operations, scale, instance scale. Okay, nope. Scale instances. Haha. Scale here now. The selection will be math greater than. We'll go into the selection. Geometry read index. We'll go into the value. The threshold will be the second, be frame times 10. Okay, and then we will scale scene time frame. We want to subtract off, actually we'll scale it by, we'll say the index. That will be our output. This is supposed to be greater than. And this should be divide. So here we now have our index. So when our index is greater than, no, less than our frame divided by 10, we scale it. If we zoom in, we can see these nesting objects. All right. So now if I apply a material here, and we make our material something semi-transparent, we should be able to see them. So let's drop the alpha way down. And of course that's holding us up big time. There we go. Awesome. Okay. So let's see. In my last couple minutes, I'm going to try to convert this, because even though it's not quite done yet, I want to see if I can use it as a starting point. So we'll do ns.tree emitting spheres. So scene time divided by 10 goes into our less than gs.math operation equals gs.math.operation dot less than a equals ts, b equals, no, a is equal to our index, b is equal to our scene time divided by 10. And so that's our selection. We'll use that in just a minute. Now we've got our less than already. We've got our UV sphere. So points equals gs.points. Count equals 60. Now we do UV sphere. Sphere equals gs.UV sphere. gs.instance on points. We've got our points equals points. Instances equals sphere. I'm sorry, that should be instance equals sphere. All right, there we go. And now we want to put this all into scale L instances. So gs.scale instances. Instances equals instances. Scale equals gs.index. Right? Yeah, gs.index, and selection equals selection. Now all we have to do, we're not going to set the material just yet. We will do that later. And so we will just return this. So let's see if this works for us. Positional argument follows keyword. Node math001 does not have an input named A. Yeah, all right. So I think what we usually do is we do a valued tuple. So let's try that. Oops. All right, so let's try returning dot geometry. Aha, the sphere needs to have its thing. UV sphere dot geometry. Is it mesh? I always get these mixed up. It is mesh. All right. All right. Oh, my meeting is coming up really soon. There we go. All right. Now let's go back here. Oh, I don't need to comment that out. Why would I do that? Okay. And let's see how it looks. We want this one to actually have emitting spheres. Let's take a look at how they vary. Points at 60, index goes there. Index should also go into the scale operation. Yeah, they should be the same one. Scale instances, instance on points. Nope, that's not the one. Scale is index, UV sphere, mesh into instance. Oh, should it be frame? It should be frame. Yeah. All right, so that did it. That replicates it. Now let's commit this all, and I can go to my... Okay, so that was a short little stream today, trying to stay in the habit, as I think it's good for me. So, thanks everybody for joining me as I teach myself Blender.